Hello my dear students, I hope you all are well. I am B S Pandey, your physics lecturer. Today we are in lecture number 23. Okay my dear students, and we are studying Newton's laws of motion. Okay, it is lecture number 23. By mistake, lecture number 22 I have been written it as the 21. It was the lecture number 22, last lecture. So lecture number 23, and we are studying Newton's laws of motion. Alright, NLM. I have been given few questions in last lecture, my dear students. We were studying about the free body diagram, the concept of free body diagram. Free body diagram. I told you to solve the question of mechanics with SAPHI. Okay? Yes. Solve all the question with SAPHI. What were the SAPHI? System analysis, free body diagram, force analysis, axis fixation, and the last one was equation writing. We will start with the examples of this SAPHI and the free body diagram. Okay. We will study today the concepts of pulley and the concepts of body if it is placed on an inclined plane. Okay. Yes. Let me start today's lecture with this very simple example. It is mentioned in NCERT, my dear student, the 10 points question. It is M, 2M, okay, 2M and 3M. A force, it is F Newton is acting from above the M block. You have to find, okay, we'll find all the question. First, let me solve this one. We have to separate all the bodies. We are going to make free body diagram. Okay. As I told you, first to represent the weight. This is mg, twice mg, thrice mg. Okay. Now, this weight is going to act over this body, and suppose it is N1. Of course, this body will also apply some force, that is the contact force, it is N1. Now, this 2 mg is going to act on this one, suppose it is N2, then this will apply the same force N2. And this 3 mg is going to apply here N3, and it will experience a force N3. And there was a force from above the M, so we have applied. Now, this is the system analysis. The system is in equilibrium. System is in equilibrium. First we have analyzed. Free body diagram we have made, and the force analysis we have done. Now the axis fixation will fix axis, the positive one, like this way. Alright, now the equation writing. Since the net force, it is 0 for this body, you can write free body diagram 1, 2 and 3. So FBD 1. The net force is 0, then the total forces in downward direction should be equal to the total force in upward direction. In upward direction, there is only one force it is acting, N1. So this N1 will be equals to F plus mg. Why? Because this F is also going downward and mg is also downward. So this N1 equals to F plus mg. That's it. This is the free body diagram 1. Now, of this free body diagram 2, you can write here the FBD 2. I have written already. Let me solve. All the forces in upward direction, this will be the positive, and all the forces in downward direction will be negative. If you add that two forces, it will be equals to 0. It means the positive one equals to the negative one. Now, all the forces in upward direction, how much it is? N2 it is equals to the downward forces, it is N1 and twice mg N1 plus twice mg, not more than that. Now, my dear students, you can put the value of N1 from this equation. It is F plus mg, and it is 2 mg already we are having. So the N2 we can write here the F plus 3 mg. Alright, F plus 3 mg. Now, the third free body diagram for this one. Again, the sigma f equals to 0, sigma y equals to fy equals to 0. Here you can write the sigma fy. For this one also you can write the sigma fy equals to 0. Here the sigma fy equals to 0. All the force in upward direction, it is N3. Downward force is N2 plus thrice mg. So N3, it is N2, we can put the value F plus 3 mg, already. So we are having F plus 6 mg. This is N3. Okay. Now, if you have been asked to find the force, if I'll ask force on m by 2m, what will the answer? Tell me. What will the answer? Force on m by 2m. So the force on m by 2m, it is which one? It is n. Remember. So the answer is n1. You can find the value of n1. It is F plus mg. If the values will given, you can find the answer. Now, the second question. If I'm asking force on 3m by 2m, then what will the answer? Yes, tell me the answer. Answer is the force on 3m by 2m. So the 2m is applying the force, which one? You can see this N2. So N2 is the answer. And what is the value of N2? You can find from the equation. It is the F plus 3 mg. Here the N1 was the answer of this one. Okay. Now, in this way, student, you can find the answers. Student, in NCERT, the question it is given, the 10 coins are arranged. What will the force by the 6th coin over the 7th coin? What will the force on 4th coin by the 5th coin? I hope you can solve that type of question using this free body diagram concept. Now, let me change a little bit. With Safai, we are solving all the question. You can see I'm not leaving any of the steps of Safai, and I'm quite comfortable to solve all the question if I'm having the concept of Safai. Okay, my dear student. Now, the next question. Suppose F1, it is F2, it is 2m, and it is m. If the question has been asked, find the force by m on 2m. Force by m on 2m. Then how will solve? Force and condition, system is in equilibrium. Remember, this is the condition. Alright. Okay, so make the free body diagram. 2 mg, mg. If the question is asking this one only, to find the force on m by 2m, then you don't require to solve the this question over the y-axis also. Over the x-axis you can solve the question, but I'm just training, I'm giving you the training. That's why I'm solving it in detail. It is acting over the surface in form of N1, so it will also apply the force N1. If it is in N2, then we'll apply N2. Here the force, it is F1 acting, and here the force is F2 acting. My dear students, these two bodies were in contact with each other, So this will apply the force over this one. Suppose this is the force C, and this will also apply the force. How much? It is C. Why? This is in equilibrium, and although it is in, if this were moving also, then the contact force will not change, remember. So the same force, it will act on each other according to Newton's third law, that we will study in very detail, my dear students. Now you can write the equations. Okay, here the sigma fx will be 0, as well the sigma fy is 0. Suppose fix the axis. This is the y axis, this is the x axis. All right, for this body, free body diagram 1, sigma fx equals to 0, you can write f1 equals to c. F1, it is along the positive direction, and c, it is along the negative direction. So f1 equals to c, and this is the answer. In same way, you can write for this one, f2 equals to c. So you can say f1 equals to f2. Of course, if the system is not moving, all the forces are acting, the number of forces are acting over the body will be equals to each other. All right, now the next question. Whenever you will feel any difficulty, if you feel that my speed is so fast while teaching, then let me know in comment section. I will drop down my speed, my dear student. Here another example. Now I'm going to introduce here the concepts of inclined body problem. Okay, here inclined body problems. So suppose a block of mass m is resting over this wedge of theta angle. A force is acting in this direction. Okay, now we have been asked to find the force F so that system remain in rest, that is in equilibrium. You have to find the force. Suppose this block is moving and you are pushing up so that this block is in rest. You have to find the force, this one. How you will solve? Remember students, whenever you will find this type of question, make a plus sign. Okay, listen carefully all the steps one by one. First you will make the plus sign. In which direction the weight will work? So the weight will be in downward direction, no doubt. Yes, it will be in downward direction. Let me explain here in detail, because this one is the first question. mg. All right. Yes. Now this weight will have the two components. If you will remove this force, what will happen? If you remove this force, this block will move down. Who is moving this down? This down. The block is moving due to the force, some force, and this force is coming from where? The component of the weight. It is mg. What will the component? We'll study. Suppose we got the angle between either with this axis or with this axis, x or y, then we'll able to find the component. If this will be the theta, then we'll write the mg cos theta over here. If we'll find this theta, then we'll write mg cos theta over here and mg sin theta over here. So my next aim to find the angle here, which will be the angle. So the angle, my dear student, look at here mathematically. If you apply the mathematics, you can find here this is the theta, then this will be theta. Now this is your work duty to find if it is theta, then how it will be theta. This is not very difficult. Okay, if it is theta, okay, let me explain. Here, make a parallel line to this one. If it is theta, look at here carefully. If this is theta, this will be the theta also. Look at here carefully over the diagram. If this is theta, this will be the theta. All right. Yes. This will be the 90 minus theta. All right. So this will be the theta. because this is perpendicular to each other. This was not very difficult, my dear student. Now, this mg will have the two components. One, it is the mg cos theta. We know that the axis with which the angle will be theta will take the component with the cosine, and this will be the mg sine theta. Am I right? Yes. Now, the next thing, if the force were acting in this direction, okay, so you can represent the force in this direction. If the force is going from here, you can also represent from here. This is not very difficult. Don't do argument with your brain. Use your IQ. Now, if this mg cos theta is acting over the wedge will apply a normal reaction. Am I right? Yes. So, the normal reaction will be in upward direction. My dear students, all the forces I have been represented here for the body. Remember, not for the wedge. Let me draw here the body. This is the body. For the wedge, the forces will be the normal reaction over the wedge. Okay. Yes. This is the triangular wedge. Okay. Now, if this system is in equilibrium, what will happen? The net forces will be zero along the two axes. Now, our next aim to find the axis. To decide the axis, let me decide over the inclined plane only. Oh, sorry. This is the x-axis, this is the y-axis, and this two axis will be considered the positive. No problem. Yes. Now, this is your x-axis. Remember, don't find this x-axis, y-axis all the time. Now, this is your x-axis over the plane. That is the parallel to the plane, and perpendicular to the plane. This will be the y-axis. Okay. So, let me write the answer, the equations. Equation will be, this f will be balanced by mg sine theta. Mg, why this sounding? Yes, mg sine theta, and this n will be, so the first equation, and this n will be equal to the mg cos theta. The second equation. Okay. So this question I will solve, and number of questions it will be asked, you can solve. Okay. Let me discuss one more question. For the inclined body problem. One more question, my dear students, I am going to deal here. The angle theta, let me take the value this time, 37 degree. Two bodies. Okay, two bodies. One it is 5 kg and another it is 10 kg. Now to apply the force from here to keep this block in a static state. How much force Motu has to apply? If you can solve, then try to solve this question. F will work so that system is in equilibrium. Why you are sounding, my friend? Yes, so that system is in equilibrium. You have to find the force. Okay, let me solve. If you can solve, pause the video and try to solve, and then compare with my answer. What I told you, my dear students, to separate the bodies, because the two body we are having now, we'll separate the body. The first thing, in case of incline, we will draw a plus sign. One perpendicular to the plane and another parallel to the plane. This is the angle theta, which is 37 degree. Now, N1, this is N2. These are the force acting on the body by the surface. Here it is 5 kg, so we'll write here the 5g, and here the weight it is 10g. Remember, my dear student, this g is not the gram but the acceleration due to gravity. Don't confuse. Now the angle, my dear students. So as I told you, and find the angle in previous question, here I am giving you the trick to remember. Remember, my dear students, angle always made with the perpendicular axis which is over the plane. Okay, angle, this weight will always form the angle with the y-axis. Try to remember. This is also theta and this is theta. So easily you can break the component. This is 5z cos 37 and here the 5z sine 37. Alright, here the force were acting since both were in contact. C and this is C. This is force F. Okay. Now this will have the two component, one along this one and another along this one. 10g cos theta and this is 10g sine theta. Now you have to write the equation. Look at carefully. I am writing the equations for this body. How many forces? Now let the axis y and x along this one. Suppose this free body diagram 1, free body diagram 2, FBD 1. I am going to write the equations. Free body diagram 1 for this one. Here the forces in this direction are the positive. So the C plus 5z sine 37 is equals to how many forces in this direction? It is F. Alright, this is along which axis? Along x-axis. Now along y-axis, sigma Fy equals to 0, and along the y-axis you can write here the N1 equals to 5z cos 37. Here the 5z cos 37, 4 by 5. You can solve. It is the 2840 Newton. Alright, and this way you can solve the value of this one also. But here C unknown, so solve for the second free body diagram. FBD 2 for this one. In this direction, along the positive axis, we are having the force 10g sine 37. Okay, and no more force in this direction. In this direction, we are having a C. So here the C will be 10g. I am taking the value of g. It is 10 meter per second square for simplicity. Simple calculation. And sine 37, 3 by 5, 60 Newton. Okay, my dear students? Yes. So you can find here the C, it is 60 Newton. Then you can find the force, how much force required to stop this block by motor. Okay, my dear students? Now, my dear student, we will study another topic. It is the basically concept, and it is force on a string, cable, rope or thread, and that is called the tension. So give the heading tension. You can write tension is the form of force, my dear students. Tension is the form of force which acts on rope, cable, inextensible string or metal strips. Metal strips. Okay. So this is the form of force, and its SI unit will be Newton because this is also a force. Okay. Now some properties of tension we should keep in our mind. And what is that? It is on tension, the first tension will be uniform, okay, uniform throughout if a string is massless, and we will suppose massless string as convention, which is not practically possible. The second, T will be single on one rope if it is bent or get turned, tension will be single. This tension will not change. If a knot is present, then tension will change. What does it mean? Suppose this is a string. Alright, it is tied between 2 points. Tension will be same throughout the string, but as you will put a knot over here, you will tie another string and suspend a body, then in this case, of course, it will elongate a little bit, and now the new tension will be changed around the knot. Here the tension, and here the tension you need to suppose different. It is T1, T2 and T3. Alright, you have to study this one. This is the very important. Now the next thing about the tension, on a string of having some mass, the tension depends upon mass per unit length. You can write the tension depend upon mass per unit length on a string having some mass. That we will study in our examples, in our question. Okay, but these are the simple properties of tension, my dear students. Okay, now after this tension, we are going to study the concept of pulley, and we will study the pulley mass system, PMS, pulley mass system. What do you mean by the pulley? Might be you have seen the pulley, the rope it is attached to carry a heavy block, okay, from top to bottom, or to raise a heavy block, it is attached with a pulley. Might be you have been seen in elevator or lift, it is the internal mechanism, but you can see it is above a pulley is joined over which rope runs to keep the wedge up and down. This is the pulley. Suppose if you will hang a mass from here, suppose it is M1, and a force you will apply from here, then you can hold this mass by pulling down this rope, and this pulley will rotate. If you will pull this end of the rope down, this pulley will rotate and this will move up. Okay, this is the pulley. So my dear students, the pulley actually, if it is massless and frictionless, remember, you will study this pulley in 2 chapters. One, it is the Newton laws of motion and friction, and the second, it will be the rotation. Here in this NLM, Newton laws of motion, you will study all the pulleys will be the massless and frictionless, but in rotation you will study all the pulley, it will be having some mass, some radius, it will be given. There will be study about the moment of inertia also. Okay, and we will apply all the laws that we will study over here in that rotation also by changing its figure. Now, here the pulley is massless and frictionless. Then in this case, remember tension over the string, both the side, the pulley will be same. Here the tension T, here the tension will be T. One more example, but here the string change, tension will change. You can see this is not the same string. One string it is goes over this one, so this is the same string, that's why the tension is same. But here the another string you haven't taken, so here the tension will be different. It is suppose T1. One more property of tension, my dear students, I forgot to explain. It is the string change, the tension will change, and another one, it is the property of the tension, which is the very important. Kindly note down. Tension must be away from the considering body. You are considering a body, then tension must be away. For example, here the tension will be in both directions, here and here. But here the considering body is this one, okay, this one, the considering body, then you have to apply the tension in upward direction, okay. This is away from the body, this is the body, and the tension is away, it is away. If you are applying, let me draw here the tension by the free body diagram. For this body it will be in upward direction, and for this pulley the tension will be in downward direction. For considering body, tension always away from the body. Try to understand. The tension must be, and recall again and again, try to remember again and again, the tension must be away from the body. Tension must be away from the body. Why? Suppose this some weight of this body is acting downward, so who is keeping this block in static state? Of course there is some force in upward direction, and the tension is that force which keeps this block in static state. So tension must be away from the body. Try to remember. Now one more example to understand the concept of tension, because the questions I will solve in next class. Once you will understand the concept of the tension, how this tension act, where this tension act, then you will be able to solve the question, my dear students. Okay. Look at here. This is the pulley. The block is suspended. Another pulley it is. And another block it is suspended from here. Try to understand. Now I'm going to represent here the tension. This is mass M1, M2. This system is in static state. Might be the system will move. If it is moving downward, it will move upward. Okay. Anyways, we have to understand how the tension should be considered. Look at here carefully. First, we'll draw the free body diagram. Cut all the strings, all the string, all the string. Now, start applying the tension. Look at here. This string is starting from this point. It is going up and this way. So this is the one string. It is passing over two pulleys. So it is tension. It is T1. Alright. Over here it is T1. Why I am applying here the two tension? For this pulley it is in upward direction. For this pulley it is in downward direction. Here it is also T1. So this all tensions are same. And if it is massless and frictionless, then only those tensions are same, my dear students. Okay. Here the tension it is T2. Here the tension it is T3. That's it. This is the concept of tension. If you try to apply the force, weight, then you can write here the M1G and here M2G. That we will study in very detail in the next chapter. Okay, now the next one and the last one. Then after we'll close today's lecture and we'll start the next lecture with this questions. The number of questions we'll solve on the basis of Newton's first law. Then we'll study the momentum and change in momentum, and then we'll come to the Newton's second law and we'll study the concepts and the problems of constrained body. Okay, here This is the angle theta. The pulley, the body, again the pulley. Oh wait, yes, here the mass M1, M2, M3. I'm going to apply here the tension, my dear students. Look at here, and all the forces I'm going to apply. You should be very keen to understand this type of question. Forces. This is the M3Z. Here, M1Z. The theta will be here. M1Z cos theta. Here, M1Z sin theta. N1. Here, suppose N2. Here, M2Z. My dear students, remember, don't apply the normal reaction over here also. It is in air. Okay? It is in air. So there will be no normal reaction. Now the tension. Cut the string. T1. Cut the string. It is T1. Cut the string. Here the T2. Now you can see that the string is being changed. And here also the same string T2. So this is all the forces. Okay, my dear students? This is all about the today's lecture, my dear students. Next lecture we will start with this type of question. Thank you very much.